So we want the equation for this graph, and it's a straight line. Hopefully you can see that. But since it's a straight line, it's linear. And since it's linear, we are expecting slope-intercept form. So y equals mx plus b, m being the slope, and then b being the y-intercept. Okay, so the first thing I would probably do on this one is find the y-intercept, because I can just look at it. And I see the y-intercept right here at this ordered pair, 0, -4, which tells me that the y value there is -4. So I can just put in -4 as my y-intercept for the equation. Next, I need the slope, and there was 1, 2, 3 other ordered pairs we could use. I'm just going to use the two that are right next to each other. So to find my slope, I'm looking for rise over run, and my rise here goes up, because I'm going from the purple one to the green one. That goes up 1, 2, 3. You could count boxes as well, 1, 2, 3 boxes. But it is going up 3, and then from there it would have to go to the right 1. Now 3 over 1 I can simplify to just 3, which makes it easier to write into my equation, which now shows y equals 3x minus 4. So you'll probably see stuff like this on the assignment too, not just nonlinear ones or exponential ones, which we're going to see today during the lesson, but you'll see these types as well. You have to be able to do both. Here's our objective for the day. I can write exponential equations from tables, graphs, and word problems. Like I said, we're not only just doing exponential equations, but also linear as well. So you have to keep that in mind. When you see linear situations, you have to be able to write those equations. The other thing too, you don't have to write this down for the objective, but the mastery quiz is next time. We'll be doing that right after the bell work. So linear, we've seen this slide before. Remember, we're looking for changes that just have repeated addition or subtraction. And that repeated addition or subtraction as a ratio becomes our slope. And then the y-intercept is just where x is 0 in the table if we have one. If we were to see a graph that's linear, we know it's a straight line, just like we saw in the bell work. But again, the main thing with this is that we see repeated addition or subtraction. So you just keep adding, for example, maybe $1 every time, or maybe you lose 3 strands of hair every year, or something like that. You see what I'm saying? So you'd lose a specific amount every time, and it's a specific value. Exponential, though, is where you're multiplying or dividing by a specific value. We don't actually divide, we end up just multiplying by fractions, so we'll have to keep that in mind as well. But changes by multiplication or division, we're just looking at the multiplication, which is why it takes on this format. We've seen this before, where a is the starting value in, or on the graph, it's where x equals 0, the y-intercept. And then you're repeatedly multiplying by some value. That's the base, which is what it's supposed to be. The base is, in an exponential expression, is the value that is being repeatedly multiplied. The other thing we'll see is that these graphs tend to curve this way. And so if they're curvy, we know that it is something that is exponential, and then we can write it in this type of format. We've seen this before. Again, you're looking at a starting amount or value. This is where the x is 0, either in the table or on the graph, which means that we're actually looking at, this would be a y-intercept, if you're looking at a graph. Now, after that, once you figure out what this is, if you're looking at a graph, then you're going to find out what you multiply over and over, which is the base. And then the x here, since we don't know how many times it's going to be happening today, we're just going to keep this as an x. But we can figure out what's being repeatedly multiplied with this base formula. Now, in order for this to work, the x values have to go to the right one. Okay, so if we see that the x is changing by anything other than 1, usually it'll be like 2 or something like that, then we can't use those values. The x have to go to the right one. If that's the case, take the second y value with the x's and divide it by the first one. This will tell you what's being multiplied repeatedly. And then once you figure out the base, you can put it into the equation, but you should check as well. Check those values that you're looking at. Sometimes this can be a fractional value, and that's okay. Sometimes it's just a whole value, and that's okay as well. Sometimes it's a decimal, doesn't matter. You can multiply by decimals, fractions, or whole numbers, it doesn't matter. So first up right here, we have, we just have to figure out if a and x are either positive or negative. And you'll see problems like this on the assignment. Now, we don't really look at it like this, but you're going to see it on the assignment, so that's why we're going over this. Usually, if the x is negative, which is kind of important, then we're going to be using fractional bases instead of making the x a negative, but we may see that as well. So right here, let's start with the a's. Okay, so between these two, a is positive. I'm just going to use a plus sign there. And that's these two top ones. So that means that this fraction, or this graph, so if a is positive on these graphs, we look at these two right here, and the thing that they have in common, this is important to remember, is that they're above the x-axis. And that's all we're going to look for now. So if you were to look at these two, now you see the x-axis, which is the horizontal number line on the graphs. So I can label these. If this, down here, these two graphs, we see that a is negative, but again, this is because it is now below the x-axis. Okay. So if it's below the x-axis, we expect a to be negative. If it's above the x-axis, we expect the a to be positive. The other thing that we'll have to figure out is the x's. So we see over here, x is positive here on the left, and x is positive here. Now, you can decide for yourself how to determine this, but for me, I see going to the right. So all of this is to the right. I see that my x's, they kind of like split, or they're going away from the x-axis. So if I see that, then I know that the x is positive. Okay, again, if I see that from left to right, to the right, I see that these are going away from the x-axis. But over here on the right side, these two graphs on the right, again, we will be looking going to the right on the graph. But I see that over here, x is negative, okay? So what's happening? If we go to the right, this is going to make x negative, but I see it's getting, the graph is getting closer to the x-axis. Okay, so right here, I see that these make x negative because they're getting very, very, very close to the x-axis as we go to the right. Over here, as we go to the right, it's kind of splitting away from the x-axis. And again, all of this is just a visual check. We're not asking you to calculate anything other than positive or negative, but you can tell all this stuff just by looking at the graph. So on this graph, first thing I notice, at least for my a value, right? It's saying is a would be positive or negative, x would be positive or negative. I see here, I'll start with the a, but this graph is above the x-axis. And since it is above the x-axis, this makes the a positive. So I know this is positive. I say, all right, a is going to be a positive. All right, so that's a. What about my x, the exponent? Well, I see that going to the right, that this graph is getting very, very, very close to the x-axis. Okay, so it's getting closer, and this is going to the right. It's getting closer to the x-axis. Okay, since it's getting closer to the x-axis, that is going to make this x is negative. So over here I'll say this one is negative. And that's all we need for this one, and that's all you'll have to do on these types for the assignment. Could we find the equation for this? Yeah, of course we could, but let's look at other examples for that. So we want the equation for this graph, and the a value right there, y equals a times b to the power of x. I know this is exponential because of curves. If it was a straight line, then I would expect a linear equation, but it's not a straight line, it's curved, so it's exponential. The a, this is my starting value, as we've seen. It's also where the x is 0, or on a graph, it can be easily seen as the y-intercept. So if I can just find where this graph goes through the y-axis, which is not labeled here, but I can label it now. The y-axis is the vertical number line, so it's up and down right here. I see that the line goes through the y-axis at this point, which is at 0, 3. So that means that my y-intercept I would just show as 3. Then we say, well, what is 3 being multiplied over and over and over? And then after that, we can raise it to the power of x. Well, the next ordered pair that I see is this one, which is shown as 1, 6. Now, I'm going to show this a couple different ways, but just from that information that I have, I can make a table of x and y. I would start with the first point on the left, which is showing as 0, 3, which is my y-intercept, and then the next one, going to the right, the next one is 1, 6. So from this, you see that the x goes to the right one. That's important in finding my base, because if it went to the right one, 2 rather, then I would have to be finding other values. But the x goes to the right one, so I know then to find my base, I just take the second y value, which is 6, and divide it by the first one, which is 3. 6 divided by 3 is 2. Let's clear that up. So that means that I would be multiplying 3 by 2. And we can see that right here. 3 times 2 would be the 6. And the next one would be 6 times 2, which would be way up here, about right there, be 212. Now in the table, we can see this as well. 3 times 2 would be the 6. 6 times 2 would be the next value, which is 12. And then you can continue this table on. So that would give you this ordered pair, 212. So again, this, just figuring out what I'm multiplying by the base, that's what I multiply over and over and over. So that is my base value. I have y equals 3 times 2 to the power of x. And that is my equation. Again, we're always using an x exponent. Even though on the last slide we were looking for like positive, negative stuff, that's only if we have a base that's a fraction that we really have to worry about that stuff, at least when we're just writing the equation. Now that's good, and being able to look at a graph and find your equation is good, but you can actually check. So this is where we get into the calculator business. So everyone's going to need their calculator. We're using the TI-84 Plus, and in this calculator, okay, if you look at the top left, you're going to see this button, y equals. This is where you're going to enter the equations. At the very top right of the calculator, you're going to see this button, and it is kind of thin like this. It says graph. This is how you're going to actually access the graph of the equation. And we've seen this one before. This one's just one button above the divide button on the right. This is the exponent button. So if you need it to put it in an exponent, you're going to use this button, which we will. So this is an equation that you could put in, right? We're going to do the other one, but this is y equals 2 times 3 to the power of x. So you push y equals, then you type in 2. You got to clear it if there's any equation there. You say y equals, then you just type in 2 times 3. Then you got to make the exponent, so you push this button. Looks like an arrow, but it's actually called a caret button. Then you push the x button, which is 4 buttons above 7. It's right to the right of the alpha button in green. Now, if you push enter, you're gonna say to the calculator, that's the equation that I want. And if you push graph, it's going to show you that graph. So on the graph that you see for the calculator, it may look something like this. Something like that, okay? And that would be for this equation. Of course, we're going to do the other one, but if you were to type this one in, you'd get something that looks like that. Take 30 seconds, see if you can type this in to the calculator, into the graphing function, and then see into the function part of the calculator, and then push the graph button to see if you can find that graph, okay? About 30 seconds, 1 minute, something like that. So, of course, we're not given the equations first, right? Like the last problem. We're given the graph, then we make the equation, but then we can actually check the equation in the calculator, all right? Okay, so for this one, this is a new equation, so we're going to put this into the calculator, all right? So you're gonna type that y equals button in the top left. Now you may have to clear out the equation. If you do, just push the clear button, the one that we had done before. But we're gonna type this in, 3 times 2, and then I want an exponent, so I'm gonna push that button. It's right above the divide button. It's a caret, or you can call it an arrow if you'd like. Then one button to the right of the alpha button, you're gonna see the x. It has other stuff on there, t, I think that's theta, and then n. Okay, then you're gonna push enter. Now you're going to want to see the graph, because that's the equation, so just push the button in the top right that says graph. And when you do, your graph may be kind of centered like this one, but you're going to see something that looks like this one. Something like that. Okay, and that's the graph you're looking for. In fact, I think, let's see, let me put this in. I think when you put this into the calculator, oh, that's not what I wanted. I think when you put this into the graph, because it's going to graph it for you. Yeah, that's it. Okay, but there's more. There's actually more to this than what we're seeing right here. Okay, now that's the equation. We saw the equation and then we saw the graph together, right? But now what we're going to do is look at the table on the calculator. Well, you can find the table, and you can actually make a table from pushing trace on the calculator. So if you have a graph and you push the button that says trace, you can find it in the top right. It's right next to graph button. If you push trace, then you can actually enter x value. So on the calculator, right, we're still on that equation, y equals, what was it, 3 times 2 to the power of x. So right now, if you push trace, and then you say 1, push 1, and then push enter, then at the bottom of the graph, it'll say x equals 1, y equals, oh, what is it, 6? I guess that's the ordered pair, 1, 6. Okay, now let's try this again. Push trace. Do this again. Push trace in the top right. Now you're going to push 0, and you're going to push enter. This is telling the calculator, tell me what the y value is when x is 0. So at the bottom of the screen, you'll see x equals 0 and y equals 3, which is the ordered pair, 0, 3. Okay, which again, if you wanted to make a table, that's good. But as it turns out, the calculator will make a table for you if you just push the table button. Now on the calculator, take about 10-15 seconds, look at your calculator, see where it says table. It's not actually on a button, but it's right above it. See if you can find where it says table. If you look at the very top right, you'll see it says graph. Right above graph, and I think it's blue, it says table. Now, because this is in blue, we have to push the second button. So you push the second button in the top left, then you push graph, and the calculator will make a table for you. So it looks something like this. When I do it, oh, it's showing me lots of values here, but it's showing me 0, 3, and it's showing me 1, 6, and 2, 12, and 3, 24, and 4, 48, 5, 96, and 6, 192. Okay, now as it turns out, if you just scroll through the table just by pushing up and down, you can go into the negatives for x, you can go down further and see what values of y it gives you. Eventually these are going to get so big that it'll probably show you some kind of scientific notation or something like it, but maybe it's calculator E notation. Either way, this makes the table. And it's actually the same exact table that we have right there, right? Remember this on the graph, we had made our own table from the 2 ordered pairs it showed. Once we see that these match, we know that our equation is good. Okay, so there we go. We have the table that we made right here. That's the one we made earlier. This is the one that the calculator gave us right there. But again, we can see that these values match as we go down. You can see the y values are being repeatedly multiplied by 2 as you go down this. So again, the purpose of that calculator is to check what you had. All right? And then once you have that, then you're good to go. So here we have this graph. take 1 minute, see if you can write the equation for this graph, then we'll go over it. Okay, now hopefully you have your equation. Test it in the calculator, see what you get. Check your table and your graph, and then we'll go over it. Okay, let's see how you did. So I'm going to start with my A, because I'm looking at a graph. I'm looking for the y-intercept there. It's my starting value. And I can see this line goes through the y-axis right here. That's at the ordered pair 0, 4. So it's going to start with a value of 4, and then we're going to multiply it by something. Well, if I go to the right on my graph, I don't see any clear values that I can use, right? Like right here, the x is 1. But I can't really tell what that y value is. Same down here, and then it just gets smaller, smaller, smaller. Now, if we've done this before, and I'm going to do this twice, I can see that this is going down. First off, the graph is above the x-axis, so I do expect the a to be positive, but it's getting closer to my x-axis, so I would expect this x to be negative. But first, I'm going to do it just kind of the way we have been. What I need then is another ordered pair that I can use. And I'm looking up here. It's way up here in the top left. That's -1, 12. Now in a table, which I'm going to make myself, we'll check it with the calculator later, you always need to start with the left point. Okay, so the first point that I have on the left is -1, 12. So that's my first point, -1, 12. And then we have the y-intercept 0, 4. Because remember, we're trying to find the base at this point, and to find the base, the x's have to be in order, which places the y's in order. And to find the base, all we do is take the second value, which in this case is 4, and divide it by the first y value, which in this case is 12. When you put this in the calculator, you're going to get 0.3 repeating, but I push math, enter, enter on the calculator, and it will change this into a fraction for me. That's nice, because now I have the number that's being repeatedly multiplied by 4, which is 1/3. And this will be to the power of x. So this should be my equation right here. So if I wanted to write this with a positive x exponent, sorry, a negative one, a negative x exponent. If I wanted that negative x exponent, because I see that this line is getting closer to the x-axis as I go to the right, I can. So this would be y equals, it's the same starting value of 4, but if I want to make that x a negative x, then I kind of go back to seeing, well, from 4 to 12, what would I have to multiply 4 by to get 12? And that would have to be 3. So either one of these are actually the same equation. And the reason why this works is because, and this goes back to 8th grade, if you have a negative exponent, it really just reciprocates the base. So this one we would look as 3 over 1, but reciprocated, which changed the x exponent into a positive, makes this 1/3. I tend to kind of shy away from that stuff, but it's okay to use this negative x exponent if you'd like. So these equations, again, I see that this graph is getting closer to the x-axis, so you could use a negative x exponent if you'd like. But first, since it's a graph, it's a visual check to find the y-intercept, and that's the value we start with. Okay, and I see it's going right here through -2, 0, -2. But I'm only worried about the y value of -2. So I'm going to keep that there. That's the value we start at. And to start here also, since my x would be negative, since it's getting closer to the x-axis, I'm going to keep my base as a fraction and keep my exponent positive instead. But I'm going to show it both ways. Now, for this to work, to figure out what I'm multiplying, I've got to find any other ordered pair on this graph. And the only other one I can tell is this one right here at -1, -6. So once again, we go back and we say, I'm going to make a table here, x and y. I've got two values. Again, always go from left to right. So I have to start with -1, -6. -1, -6. And then I'd use the y-intercept 0, -2. And this is going to help me to find my base, which is what I need next. Since this is an order for my x's, -1 to 0, and it goes up to, or it goes to the right one. Since I do want to find my base, I take the second y value, which is -2, and I divide it by the first y value, which is -6. This is going to give me 0.3 repeating, push math, enter again, and you're going to see this is 1/3. So that means that you take -2 and multiply it by 1/3, and then this would be to the power of x. Y equals -2 times 1/3 to the power of x, because we did find our base. Or if you want to make that x exponent a negative, you can, and you're still going to start at -2, but I would multiply this by a base to the power of -x. Again, it's just, since I'm making the x a negative exponent, just reciprocate the 1/3 into a 3. So either one of these will work. Now you can try both. Try the calculator, okay? Put this into the calculator, see what the graph looks like. Or this one, doesn't matter which one you want. Just put one of these into the calculator, check your graph, make sure it looks like this, and then check your table as well. Make sure that it has these values. Let's see what it gives us. So in my calculator, I've got -2 times, I'm going to use 1/3. Since it's 1/3 fraction, I'm going to have to use parentheses right there. So 1/3 to the power of x, enter. Okay, so I push graph, and on my calculator, it's showing this. And this may not look great, but I'm trying. Something like this. Okay, and you could check. If you use the trace function of the calculator, if you push trace, right there, it'll say 0, -2. X is 0, Y is -2. If you push -1, enter, it'll say, well, if X is -1, then Y is -6, which is that ordered pair. Okay, so the graph is good, but let's try the table as well. So push second graph, and the table, let's see what that shows. Starting at 0. Yep, it's showing in the table on the calculator. 0, -2. Now the other values, it's got 1 and -0.6 repeating, and then 2 and -2 repeating, 0.2 repeating. If I push up, it'll take me up to -1, and it'll show me that -6 as well. So again, the table that's on the calculator matches the table that we had before, and you could continue going up if you'd like, but I'm going to skip that. So find the equation of this graph. You guys take a minute, try it out, check it on the calculator, make sure it's good, both the table and the graph, see how you do. 1 minute. So if I was doing this first by hand, I would look at my graph, right? And I'm looking for my y-intercept because that's my a value. So again, if I can just find where this graph goes through the y-axis, then that's a great start. And I can see it's going through right there. Okay, so that's at the ordered pair 0, -5, which means the a value there is -5. I don't really need parentheses around there. You're welcome to do it, but I just don't need them. Okay, well, what am I multiplying -5 by as I go? Well, this graph is getting further and further away to the right from the x-axis. So I am expecting a positive x here, so I'm not going to need to write this out twice. But I need some other ordered pair to work with, and the one that I see is right here at 110. So again, as a table here, I'd be looking at 2 ordered pairs. I've got 0, -5, and then the second one there is at 110. So from here, yeah, make sure you keep track of your signs right there. I messed up. 1, -10, and so I've got to keep that as a -10. Thank you. So again, I want to find my base here, and the good news is that I see that the x's go to the right one. That's a good start, because that means since I'm seeing that this graph is curved, it's exponential, and so I need to find a base, right? Take the second y value, which is -10, and divide it by the first y value, which is -5. If you divide these, this means that you're multiplying -5 there by 2 over and over and over. And again, we're going to use an exponent of x because we don't know how many times it's going to occur. Okay, so this means in the table that we have, you take that -5, multiply it by 2 to get -10. If you wanted the next value, you take -10 and multiply it by 2 to get -20. So the x value would be 2 there. All right. Now, again, we can check this in the calculator. So I got -5 times 2 to the power of x in my calculator. When I put this in the graph, again, on the calculator, I'm estimating, but it looks, something like this right here. If I see the table, which I kind of do want to see, it's showing me starting at 0. Again, let's compare this with the table that we have, but it's showing 0, -5. It's showing 1, -10, 2, -20, 3, -40. And it goes further down than that, but this is enough to show. I have 0, -5, 1, -10, 2, -20. It matches everywhere. So, yeah, this means that our equation actually is good. It is the equation that would create this graph right here. Now, a quick review on this. Remember the ordered pairs on a graph? They have to make the original equation true, which means 0, -5 means if you replace the x with 0 and the y with -5, you get a true statement. Or the second order pair, 1, -10, if you replace the x with 1 and the y with -10, you get a true statement. Or 2, -20, replace the x with 2, the y with -20, you get a true statement. And it goes down further in this table if you want more values. But again, this is to prove that all these ordered pairs on this graph would make the equation a true statement. So for problems like this one right here, where it's just kind of giving us some kind of scenario, the problem that I see right here is that I have round 1, which has 1 dot. I have round 2, which has 4 dots, and round 3, you can count them, but that's 16 dots right there. Now, this is not a graph, so I'm going to want a table for this one. I got x and y. Now, which one's x, which one's y? Well, from what I can tell here, the number of dots in this sequence will depend on how many rounds there are, or what round it is. So right here, the first set shows that round 1 has 1 dot. So round 1 has 1 dot. And yeah, I've given myself some space right there on purpose. We'll come back to that though. The next up, I see round 2. Round 2 has 1, 2, 3, 4 dots. And then next up here, round 3, again, you can count them, but there should be 16 dots right there. So I see it's going up 1 round every time, which is good for my x's. And you could probably even tell what's going on with the y's at this point, right? You got 1 and then 4 and then 16. This is definitely exponential. It's not linear. It's not adding 3 every time or 4 or whatever. Something's being repeatedly multiplied in here. Now in my equation, that's going to be the easiest value to find first, just because we have enough information to find it. I can't find my y-intercept yet because for my y-intercept, I would need round 0, which I do not yet have. How many dots are there in round 0? Well, we got to figure out what's happening to the dots first. And again, I think this may kind of show what's happening. You got 4 lines there, 4 lines there. But we can use the same method that we've been using. If I want to find the base, which I do, and I can see that the x values are going up by 1 every time, that's fine. It doesn't matter where I choose them, but if I take the second one, which in this case is 4, and divide it by the first y value, 4 divided by 1 there would mean that we're just multiplying by 4, which is why you see 1, 2, 3, 4 lines out from every single dot as you go down. In the table, this is shown because you'd have 1 times 4, which is 4. 4 times 4 which is 16. And if you were to continue this, 16 times 4 is 64. So in round 4, there would have been 64 dots. I don't want to draw that. I don't think you do either, but if you do, you're welcome to. So in my equation, I now know it's being repeatedly multiplied here. The base is 4. Okay, it's going to be to the power of x. But what did we start with? That's the other question. Well, to start with, this is my a value. It's my starting value. The starting value is always where x equals 0. And in this case, that starting value in context is for round 0. So right now, I don't have round 0, so I've got to go back to make round 0. Okay, so I'm going from x is 1 back to 0. Now, going down this table, if I multiply by 4, to go back in the table, I would have to divide by 4. So I'm going to go back over here. I take 1, divide by 4, and then we get, well, you could get 0.25 if you like, but I'm going to keep this as a fraction of 1/4, which I'll put in parentheses. So if you want to use the decimal, of course, that's okay. So it's still multiplied by 4 to the power of x, but if you want to use the decimal of 0.25, feel free to do that. Now, if you were to put this into the calculator, again, I'm not so concerned about the graph because they didn't give us a graph, but I would want to see the table there. Just put second graph, and yeah, you'll see these values as you go down. In fact, I think they give us the fractional value, so or the decimal. 1/4. Again, I'm putting that in parentheses times 4 to the power of x in my calculator. Second graph. Yeah, it's showing 0 and then 0.25, 1, 1, 2, 4, 3, 16, 4, 64. Apparently 5 would be 256. So again, it matches the table that we have, which came from the values that we had started with in this situation. But either one of these, if you put them into the calculator, will give you this table. Again, I'm not checking the graph because we don't have one to check, but you should be able to check that table with the calculator. So let's write an equation for this table. Now, a mistake that we see often with this one is students want to just, right, because here it's not showing my y-intercept, which is the a value. In order for that to happen, I need to look at week 0, which we will, but not yet. I want to figure out what's being repeatedly multiplied. So some students, what they do is they look at this table and they just say, well, take the second y value, which is 12,500, and divide it by the first one, which in this case is 500. But if you do that, you're going to get 25, and you can check this. So 500 times 25 is actually 12,500, but 12,500 times 25 is not 62,500. It'd be 312,500. So that's not going to work. Why does it not work? It's because over here on the left, you see the x goes from 1 to 3. That's to the right 2. What we need is to go to the right 1 on the x value. So we can't actually use these values to find our base. I need 2 consecutive values to compare. So if I look to the next one, from 3 to 4, that one goes to the right 1. So if I wanted to, and I do, I can use the next 2 values. Okay, so that means I'm going to take this 62,500 and I'm going to divide it by 12,500. And when you put this into the calculator, you're going to get 5. Okay, so this means that 12,500 times 5 is 62,500. Times that by 5, you get 312,500. Times that by 5, and you get 1,562,500. So we see a repeated multiplication. So why is this not good? Why can't we use these top 2 values? It's because it skipped an x value, meaning that, remember you had 25, it would have been something times itself twice right there. So if you wanted the second value, which maybe you do 500 times 5, and that would have given you 2,500 for week 2, and then multiply that by 5 to get the 12,500. Now that's just for my base. So I have found my base of 5, and we're going to make that to the power of x. What I need is my starting value. So going down the table, right here, we see we're just multiplying by 5 as we go. So if I want to go up the table, which I do, I'd have to divide by 5. Meaning the 500, if I want to go back here like I do, I'm going to have to take that and divide it by 5. Meaning in week 0, and we can interpret this, in week 0 there would have been 100 mosquitoes. That's my starting value. So 100 multiplied by 5 every week. That's our equation right there. So we can check though. Okay, so again, let's go over to the calculator. Since I was given the table, not the graph, I'm gonna put in the equation. So I'm gonna push the y equals. I'm gonna type in 100 times 5 to the power of x. Then I'm gonna push enter. Then I'm gonna push second. Then I'm gonna push graph. because that's the table. That's how I'm going to get to the table. So 100 times 5 to the power of x. Enter, second graph. And so this is the values that it's showing me in the table on the calculator. So starting at 0 it gives me 100. At 1, it's 500. It's showing 2. 2 was not in our original table, but that's okay. 2 and 2,500. 3 and 125,000. Again, this goes on. I'm not going to show all those values because this is enough to show that it's matching the values that we have in this table. So since this table matches on the calculator what we have up here, again, it's showing the 2,500. But since they match, I know that our equation is good. Let's go and box it in. The store is discounting the price of a shirt each month that it doesn't get sold. After 1 month, the cost is $22.50. After 2 months, it costs $15. And after 3 months, it costs $10. Write an equation to represent the situation. So for my equation, I'm going to need a table here. I've got x's and y's. And we know in tables, if you're ever given a form of time, which in this case is months, that has to be the x value. The other thing we know is that y is the dependent variable, and the cost in dollars is going to depend on how many months have passed. So the ordered pairs that they give us, starting here at 1 month. So at 1 month, it's $22.50. At 2 months, the cost is $15. 3 months is showing $10. Now, I did give myself some space right here so that I can find my y-intercept, which we will find. But first, let's figure out what the base is, right? Now, I can see for my base, which I want, I see that the x's is going to the right one. So the y's, I've got to figure out what's happening to those. Since the x goes to the right one, I can figure out my base. I'm going to take the second y value there, which was $15, and divide it by the first y value, which was $22.50. So I put this into the calculator, 15 divided by 2250, and it gives me 0.6 repeating, which is kind of garbage to me. I'm going to push math, enter, enter, and it's going to show me the fraction of 2/3. So my base already I have as a fraction of 2/3. All I need at this point to finish the equation is my y-intercept. So my base is 2/3, meaning if you take 2250, multiply it by 2/3, you get 15. Multiply that by 2/3, you get 10, and you could continue this. But that's going down the table. If I wanted to go up the table, which I do, I'd take that 2250, and I would then divide it by 2/3 instead. And so on my calculator, 2250 divided by 2, putting this in parentheses, by the way, my fraction. 22.5 divided by 2/3, enter, and it says that is 33.75. Now we can interpret that, right? Because this is a word problem. So this means that right now in the table at week 0, if you let me in there, at week 0, the sweater, then what it was, a shirt. The shirt was $33.75, meaning that's the original price. So in my equation now, I know it's starting at $33.75, which then we would multiply by 2/3 as we go to the power of x. Y equals this stuff. This is my equation right there. Now, can you put this into the calculator? Of course you can. And if you put it in the calculator, you're going to get this exact same table right here, which I would recommend doing. Make sure that you put these into the calculator to make sure that your tables match or your graphs match if you have them. There's our objective. I can write exponential equations from tables, graphs, and then these word type problems, or even the situations with the diagrams. Then don't forget that we got the mastery quiz next time. Now, since this is the objective and we finished the lesson, you're supposed to be comfortable doing this stuff. If you're not comfortable doing it, that's when you're supposed to ask questions. So please do, if you have questions, be an adult, ask your questions, all right?